Alright, so similar to 7.1, we can kind of assume we can use some differentiation except for the bit that we're trying to prove. So we're trying to prove dx only for positive integers, so we can do it by induction that dx of sine x to the power of n is n sine to the n minus 1x cos x. Alright, so again, we would start with letting P of n represent the proposition, and then we'd have a look at our P of 1. So P of 1 is true since, it's true since if I look at the, let's go the left-hand side, I've got dx of sine x, which we know is cos x. So that's all fine. If I look at my right-hand side, I've got 1 times sine to the 1 minus 1x cos x, and we know 1 minus 1 is 0, whoops, and we know anything to the 0 power of 0 is 1, so we also get our cos x. So we've got our left-hand side equaling our right-hand side, so we're all good. Alright, so then we'll go on. So remember, we want to, and I'll rub that out because we don't need that. So hopefully you're doing it at the same time as I'm doing it. So our P of k, we are going to assume that that's true for any integral k. K is greater or equal to 1. And so what is our P of k? It is that dx of sine to the power of kx is equal to k sine to the k minus 1x times cos x. Alright, so we've got that all ready to use, and what are we required to prove? So our P of k plus 1, again, apologies for this handwriting. So we've got dx of, in this case, sine of k plus 1x is equal to k plus 1 sine to the power of kx cos x. Alright, that's what we're required to prove. So again, let's use our left-hand side and have a look at what we've got here. So we're doing dx of our sine, k plus 1x. And we want to use our assumption here. So which has sine to the power of kx. So again, we'll change that to sine to the power of kx, so just its format, sine x. Or the other way around, sine x sine to the power of kx. So again, we are going to use the product rule. So I'm actually going to take the sine x by itself and dx the sine to the kx plus, this time I'll do my sine to the kx dx of sine x. So what are we using? We're using the product rule to do that. Alright, so let's do it. So we know we've got sine x here, and we're timesing by dx of sine to the power of kx. Now we can do that because we've got our assumption here. So that is going to be k sine to the k minus 1 x times cos x plus, and again here dx of sine x, we know it's cos x, so we can use the fact that it's cos x. So we've got sine to the power of kx times cos x. Alright, what are we really looking for? We're looking for this side. So we want factors sine to the kx and the cos x. So they've both got a cos x. Do they both have a sine to the kx? This one does. This one is about to if I put these together, but I better do that. So I'm going to have a k and then a sine to the kx and a cos x. And this one's already got a sine to the kx and the cos x. Alright, what does that give us? It gives us that k plus 1 sine to the kx cos x. Did I do that right? Which is what we wanted. So we're going to say which equals the right hand side, and therefore our P of k implies our P of k plus 1, and therefore our P of n is true for our integral n is greater or equal to 1, and we've done it by induction.